Let me do some push-ups with
There you go. Good. Hi. So, hello there. My name is Alexander.
My name is Cook.
And this is the final demo for the final lap ECE385. So basically, what we did is we built a Perceptron out of a single-layer neural network, and we're doing face detection.
The impressive part about it is that there's no system on chip. It's all within the hardware, so everything's accelerated and very fast.
Yes, so there is no C code. Everything we build in modules, everything in systems Verilog. Everything has been built in the FPGA. So we have the project set up right now over here. The way it works is we have a camera, it's a CMOS camera, and basically it just reads and records, and we have the monitor, the VGA monitor right here. And what we did is we set up like a spot where we are going to be scanning information from, like we're going to be recording. And we're going to train the perceptron in the neural network, in the single-layer neural network, and we're going to tell what is a face or what we want to classify. Basically, it is a classifier, but we're using it as a face detection. So we're going to be training it on faces. We're going to be training it on my face, for example, and we're going to see how it works. And what it's going to do is when we train it, and when it's recognizing the faces, it will say the face over here.
The neat thing about this is that it can be trained on any object. It just takes the pixels and adjusts a certain weights to it, like a neural network would. And like Alex said, we're doing faces because we think that's the funnest and most interactive demo to do.
Yeah, there are many more applications and there are many more objects that we could classify, because this is essentially classify multiple things, but we're doing faces because it's really cool, right? So that's what we're doing. So we're gonna do a quick demonstration right now. I'm gonna go ahead and I'm just gonna show that right now my face is not being detected because we have not trained it to detect my face, and then we're going to detect it with the 1.
Okay, gonna go ahead and click reset for the camera.
Oh yeah, okay.
So all the weights are reset. They're all ready to be trained.
So right now it's not detecting anything?
And so the way it works is we'll have the object of interest inside this green box. We will put this switch up to tell it that this is what we want you to learn. Okay, so that's this last switch here. And then we're gonna go ahead and train. And then we're gonna train. So it's really fast. You don't need thousands of training sets. Right now it says face based on what it sees, and it'll continue to say face until you turn it down and tell it this is not a face. And then one click, it'll tell 0, move him back, and then it just needs a little bit more training on the face. One more, and then. So right now we already see it's kind of reacting when he moves out the way. And then it'll say face when he's in the right position, and you can kind of see. I'll have him smile, make a bunch of faces. So it's pretty robust. It's grabbed certain pixels that it determines are important to a face, and it's lowered the weight of other ones that it determines is not important to a face. So when we have him move out of the way, and we'll have let's say like a hat, right? It might set it off like a false positive. Let's see. Right. Maybe not. But should there be a false positive? So should there be a false positive, we can always train it on that false positive and tell it that it's not a face. And it gets more, as the weights get more and more trained, it'll capture all of what it's done in the weights themselves and readjusts itself so that it picks out the most important pixels that do correlate with the face. And this project kind of depends on the lighting. the way we've set it up as a proof of concept. We can make it more detailed using all of the inputs, but right now we have it as feeding as a black and white monochrome, and because of that, that's why the lighting is very important.
Yes. So this is it. This was our final demo, and we decided to do that because one, we thought that it was really cool and would be very fun to do something like this, like face detection, right? Artificial intelligence, it's coming along. It's one big thing happening right now. We are very interested in that, so we decided to do that. And then another thing is because usually people do just normal labs, like projects like video games or things like those, but we wanted to do something more challenging, something more purposeful, and something that can have applications in other fields, right? Because this can be this can be an application for many other things. It can be used in other areas. So that's why we did that. This is like the very basic of this project. And there are many other things that can be built from this single project.
And one of the challenges we found most rewarding was that there was no other resource online that we could find that implemented the Perceptron or neural network within the FPGA, just within the hardware without any software or no system on chip. And so we had to figure it out ourselves and barreling through all the obstacles and stumbling and getting back up. That was a very valuable learning experience and very rewarding now that we've finished and it's paid off in the end.
Yeah, it really feels it's very exciting, and it feels very good to build a project like that. And and I want to say also thank you to my partner.
Thank you too.
Put a lot of work, and he was working hard. We worked together. He was always there working. We were putting ideas together. We were trying many things because this, as he mentioned, this project was not like easy. We had the idea, we had a hypothesis, we had the concept of a neural network perceptron. But then, as we said, one of the important things about this is that we built everything in system Verilog. Like everything is in hardware. There's no software at all. Like everything is on the FPGA, and we had to come out with many ideas or kind of like tricks, right, to make it work, and it worked in the end. So it feels very satisfying. So yeah, thank you, Cook.
I want to say thank you too, because I really don't think I could have done anything. I think us working together had a lot of very good vibe, because Alex thought of a lot of out-of-the-box solutions that really helped us move forward when we got stuck. And I really feel like this could not have been done if we were in partners. So really cool.
Yeah, cool. So, and then thank you again. I hope you guys liked the demo. I guess that this is a new thing, right? Artificial intelligence. There are gonna be like multiple projects. We're gonna be continue working on that. We hope, right? So he wants to too. On our own, making projects. But yeah, I hope you liked it, and
thank you for watching.
Yeah, thank you for watching.